So here we go. Hello, everybody from the beautiful Lake Attersee in Austria, from where I am moderating this webinar. My name is Eva Jan, and I'm the technical leader of WIN Global, and I extend a warm welcome to all of you attending this webinar series on emerging nuclear technologies. Before we start, I would just like to tell you the sequence of this webinar. So first of all, myself and Xiaohong Chen from China will introduce our two groups to you. Then our president, Melina Belinko, will welcome you to the webinar. Then we will have our speaker, Ms. Emma Wong, who will give you an introduction to the topic of emerging technologies relevant for the nuclear field. Then we will have a question and answer session, and please put all your questions into the chat or into the Q&A part of the screen. And then we will close up the webinar. So before we start, let me introduce you to the group, WIN Global Group, WIN for Peace, and another welcome to you to our session on emerging nuclear technologies and overview. So who is WIN for Peace? Our group was founded more than 2 years ago in order to bring more women into the areas of nuclear non-proliferation safeguards, export controls, and disarmament. And our activities are across all 4 domains, in particular referring to education and training. Our membership to our group is open to all WIN Global members, and we currently have members from 4 continents. We have 30 members currently. Here are some pictures of our members. And we have 2 supporters. One is the Vienna Center for Disarmament and Non-Proliferation, the VCDNP, and the second one is the UN Office for Disarmament Affairs, UNODA, also based in Vienna. We mostly hold educational webinars as well as hybrid events. The announcements for our events are published on social media, for example, on Facebook, LinkedIn, and Instagram, and also via email for those of you who have already participated in one of our events. It is free to open to anyone to attend our events, and we have a dedicated YouTube channel where you will find the recordings of our webinars. Let me just give you a brief idea of what we have covered so far between 2023 and 2024. We have spoken about the non-proliferation regime, about the safeguard system, about nuclear export controls. We have also covered Iran's nuclear program, the EQHAN network. We have spoken about nuclear disarmament, about nuclear propulsion, nuclear weapons, the nuclear fuel cycle, some nuclear weapons-free zones like the Pelindaba Treaty and the Tlatelolco Treaty. We have looked at nuclear physics, the Comprehensive Test Ban Treaty, and the Treaty on the Prohibition of Nuclear Weapons. And this year, we have had 5 webinars so far from novel equipment used by the IAEA for its safeguards verification activities. We have looked at safeguards implementation in an SQP state without an AP, namely in Cameroon. We have also invited some former colleagues of mine from the UAE to talk about the transition from an SQP, a small quantities protocol state, to full scope safeguards implementation. We have had a so-called soft skills workshop on work-life balance and communication skills. And last not least, just 2 days ago, we spoke about decommissioning and stored liquid waste at the Chalk River laboratories. Today, we are starting a webinar series in cooperation between Win for Peace and Women in Innovation on emerging technologies relevant for the nuclear field, including their applications, opportunities, and challenges. These are, for example, artificial intelligence, digital twins, blockchain technology, additive manufacturing, etc. So we will conduct about one webinar per month. And this is the first webinar which will give you an overview of all these technologies. And the idea why we are conducting this webinar together, those our two groups, is because there are certain overlaps. On the one hand, we have all these innovative technologies. On the other hand, there are, of course, these are on the one hand opportunities also for the non-proliferation regime, for monitoring, for example, but also there are also certain challenges associated with it. So that is why we decided to hold these together. So this brings me to the end of my presentation, and may I now hand over to Cheng Xiaohong from China, who will introduce her group to us. Xiaohong, please go ahead.
Thank you very much, Eva. I'm very grateful for the opportunity to introduce WINI today. And WINI was launched in September 2021, and DG Summer is the godmother of WINI initiative. The mission of WINI is to promote innovation in nuclear, for which women have a key role.
Currently, sorry, Xiaohong, please could you put it in presentation mode? Because we only see the first slide.
Okay. Is it good now?
Press this button at the bottom right, 1, 2, 3, the fourth button to the right from the left, before the 99%, then it should go to presentation mode. Bottom right, just the button before 99%. Yeah, no. Or you can just do it like this if you prefer.
Is it good now? No.
No, it's okay. Just continue and do it manually then. Okay.
Yeah. Sorry. The mission of WINI is to promote innovation in nuclear, for which women have a key role. And currently, WINI has about 20 members from around the world, including Asia, Europe, Latin America, North America, and South America. And Confucius said once, when 3 people work together, there must be one who can be my teacher. For every WINI member, WINI is more than just a group. It's a community of volunteers that united us. Together, we engage in a collaborative learning journey, drawing knowledge and sharing experiences from one another. For example, today's speaker, Emma Wang, is our amazing WINI member, so thank you very much, Emma. WNA and IAEA are the 2 key partners of WINI. WINI has actively invited experts from our key partners and collaborators for lectures and have successfully gained their strong support. For example, these 2 webinars, the role of nuclear innovation and technology, and the nuclear and renewables. There is an old saying, it goes, if you want 1 year's prosperity, you grow grain. If you want 10 years prosperity, you grow trees. But if you want 100 years prosperity, then you grow people. WINI members have been making continuous efforts in career roadmap development For example, Florencia, Winnie's deputy leader, is putting a lot of energy in this domain, and she's just led successfully the newcomers for nuclear summer school with 80 participant countries in training courses and in mentoring for young nuclear professionals. For example, Carla, Winnie's deputy leader, is currently mentoring in annual Brazilian Nuclear Innovation Olympics. With coordination and backing of Win Global, Winnie has been an active participant in a range of events, ranging from international conference to initiative like WME Innovation Awards and IAEA ISOP Awards judging. And now,
Excuse me, Xiaohong, can you move the slides, please?
yes. And now, let me give a look back at Winnie's 2025 journey.
Excuse me, Xiaohong, you're still stuck on the slide number 3. Can you move it forward, please?
I did move it forward.
I can see when 3 people walk together.
Can you see now? No. Or would you please share my slides from your end?
Can
Thank
you
you very
close
much.
and I will look for it and
Yes.
share your
Yes.
slides. I don't know whether I have the latest version here, or it's in your email, right?
Yes.
One moment, please. Okay, just say something nice in the meantime until I find your email with the latest version. We are doing this live, and of course, things don't always go smoothly, but we will manage. So, ladies, bear with me.
And that's the reason why we need engineers.
Okay, that's the certificate. I will share the slide from the 21st of September. Xiaohong, I hope this is okay. And if anything is missing, okay, then you have to say orally, okay? So,
Yes.
let me share. So, I think we were here. Yeah, we have had this.
Yes. This is an old sayings, emphasis that if we want to grow people, if we want 100 years prosperity, then we grow people.
Right.
Yes.
So here's the
next.
program of activities. I think you were here, right?
Yes, we have a lot of program of activities. Next, please. Next. Oh, not yet. Let me give a briefing of Winnie's activity in 2025. We brought a hybrid lecture to universities. We provide webinars for early career nuclear professionals in Africa and beyond. We continue the knowledge and experiences sharing among Winnie members and with our partners and collaborators. We participated in our key partners activities through all the year, and no list can ever fully reflect the dedication, the time, the effort, the enthusiasm, and the experiences that each Winnie member as volunteer has given. So please allow me to take this moment to express the gratitude. We thank you. And dear all, yes, if you are interested in joining WINI, please refer to these steps. First, to be a WIN Global member, and then to affiliate with a WIN Global chapter. For example, Amparo, our dear WINI member, is the president of Wingspan. And then we look forward you to join WINI. WINI is young, very young, but our team brings deep experiences. And please take a look at these beautiful photos. They only capture a part of our history, and we are always adding to it. Next, please. Yeah, thank you. The combination of life and intelligence powered by energy is defying our modern civilization. And WINI is thrilled to establish and grow its endeavors in a future with clean, virtually limitless power through nuclear technology. And I thank you all very much. Dear Eva, I'm now giving back the microphone to you. Thank you for your support.
Thank you very much, Xiaohong. So, without further ado, let me hand over to Ms. Melina Belinko, who became WIN Global President at the end of last year, following the elections, and she was confirmed during our conference in Mexico. Melina is also not only a nuclear professional, but also a young mom and the president of WIN Global. So she has several duties under one chapeau. I don't know how she does it, but she's very efficient in everything she does. So Melina, without further ado, thank you for opening our webinar. And please, afterwards, would you mind opening your cameras, and we will make a group photo for our communications team. So Melina, please go ahead. Thank you.
Thank you very much, Eva, for your lovely introduction. And I must say it is only possible because we have a team, a beautiful and dedicated team. But going back to the protocol, let's say, good morning, good afternoon, and good evening to all of you joining us today from across the globe. It is very exciting for me to be part of this joint effort. And as the president of Women in Nuclear Global, it is an honor to welcome you to this timely event. As you know, we are living in an extraordinary era, an era where rapid technological advancement is reshaping industries, economies, and societies at an unprecedented pace. So emerging technologies are not longer ideas of the future. They are already here, influencing how we communicate, how we learn, how we solve problems, and indeed how we harness nuclear science and technology for peaceful purposes. And it is also with great pride that I announce and highlight our collaborative initiative. This is, as I mentioned, a joint effort between WINI and Win for Peace. You already heard about these two extraordinary also groups. And this series of webinars is a platform not only to explore innovation, but also to reflect on the broader implications for safety, security, sustainability, and international cooperation, which are key pillars for our global organization. And throughout this series, we will hear from leading voices in the nuclear field, from international organizations like the IAEA, OECD, NEA, EPRI, to some of the world's most respected research laboratories, industry leaders, as I said, and consulting firms, for instance. And together, we will delve into groundbreaking applications of artificial intelligence, of course, digital twins, robotics and drones, additive manufacturing, blockchain technologies, and much more. These technologies have the potential to transform how we design, how we operate, how we monitor and safeguard nuclear systems. But this series is not only about technological breakthroughs, it is also about our responsibilities, especially in the areas of non-proliferation, safety, and public trust, which are, as you know, key topics and key areas where WIN Global has been working with dedication and passion and responsibility. As these technologies evolve, so too must our frameworks for ensuring they are used transparently and in service of peace and development. And we are also looking at the future of how the nuclear industry engages with the world through digitalization, enhanced communication, and inclusive collaboration. And last but not least, I am incredibly proud to share that today's session, as you could see, from planning and coordination to moderation and presentation, has been led and organized by dedicated members of Women in Nuclear Global. These remarkable women, despite their professional responsibilities and personal commitments, have volunteered their time and energy and passion, I must say, to promote nuclear for peace and development. So their expertise, their commitment truly embody the spirit of women. I also want to acknowledge the outstanding reach of this event. As you can see, the attendees, also the visibility throughout our social networks. This speaks volumes about the global interest and relevance of emerging nuclear technologies, and also the strength of our international community. And in closing, I would like to express also my heartfelt thanks to our speakers, again, organizers, and you, attendees. Let this series spark new conversations, forge new collaborations, and inspiring continued innovation in the nuclear field. I wish success to every webinar of this series, and thank you very much. Enjoy this remarkable initiative.
Thank you very much, dear Melina, for your kind and inspiring words. Yes, we are all doing this on top of our normal job and as volunteers and free of charge. So thank you very much, Emma, for speaking to us free of charge, and to all of us working in the background. And by the way, before I forget, I would also like to acknowledge Holofelo Razlani, who's working at the background as Razilani, as our webmaster today. Before I hand over to Emma and I introduce Emma, I would like all of you to open your cameras so that we can have a nice photo. Me and Gabi and all of you, please open your photos. Your cameras, sorry. Can you open your cameras? I hope it works. Or do I need to give a special permit for that? I'm not sure, because I'm not such a professional with Zoom. It seems it doesn't work, Melina. So let me take a photo of those who appear now on the screen. So a big smile, please. One more, please, just in case. It's getting the image ready. And Melina, in case you want to take one as well, please go ahead, because mine is still working on it. So another one from Melina, please. All right.
Ready? ready. Yeah, thank you very much.
So thank you very much. Thank you, Melina. And before I hand over to Emma, I would like to introduce her. So Emma Wong is the lead of nuclear innovation and quantum technologies at Electric Power Research Institute, EPRI, which many of you may know. Her main responsibilities are leading the Nuclear Innovation Working Group, Nuclear Technology Innovation Portfolio, and coordination within technology innovation. She is a key interface to the global regulatory technical support organizations such as Nuclear Regulatory Commission Office of Research, industry support groups such as Nuclear Energy Institute, industry members, and other international organizations. From 2022 to 2024, Emma was on a 2-year secondment at the OECD Nuclear Energy Agency in Paris, France, as the Senior Nuclear Technology and Innovation Advisor. There, she led efforts on the SMR dashboard, which some of you may know. It's, by the way, available on the OECD website. A Nuclear Innovation 2050 Global Forum for Nuclear Innovation and Disruptive Technologies such as Artificial Intelligence. Previously, at EPRI, she was the Nuclear Innovation Lead and Long-Term Operations Lead. Her key responsibilities in innovation were focused on the nuclear technology innovation portfolio, innovation effectiveness and training, Global Forum for Nuclear Innovations, and a co-funded internal innovation startup. As the long-term operations lead, she focused on maintaining comprehensive technical basis for plant license renewals, aging management, and safe operations during long-term operations. Prior to joining EPRI in 2017, Emma worked at the Nuclear Regulatory Commission for 9 years, where she was responsible for various areas focused on operating reactors, dry storage and transportation, generic communications, rulemaking, licensing program improvements, and she interfaced with industry and other governmental agencies. Emma holds a BS and an MS chemical engineering degrees from University of Michigan and the University of California, San Diego, respectively. So a very impressive CV. Emma, the floor is yours. Thank you in advance for your talk.
Oh, thank you, Eva. As always, you did not have to read my whole bio. You could have just read the first part. It's okay. But thank you all for that. You reading all that just makes me feel kind of old that I've done so many things already, but it's okay. But so today I'm going to focus on looking at emerging technologies. I'm going to share my screen. I have the presentation, so bear with me. We hope there's no more technical difficulties. So choose this, there's that, and this. Eva, if you could just give me a check that you do see this appropriately.
Yes, perfect. Thank you, Emma. And by
Okay,
the
perfect.
way, it's okay. Go ahead.
No, go ahead. Is there something I need to know?
No, go ahead. I will say it later.
Okay, perfect. So yeah, I was asked today to talk about emerging nuclear technologies, just to give a brief overview, kind of kick off our seminar series that's already been covered. So I'm not going to cover it any more than it already has. And then I look forward to questions coming up after this. So some of the topics that I've been asked to talk about are on this slide. And when you think about what an emerging technology is, it really is, as I put on here, an early stage solution that has the potential for a significant impact. As Melina already said, some of these technologies are already here, but could even have a bigger impact going forward and into the future. Of course, the biggest one that we all think about is AI, or artificial intelligence. The new image I like to think about AI, it is a layered cake, because while artificial intelligence is at the top, you have different layers on what it could mean and how AI functions. At the base, there's data, the neural networks and machine learning. You don't necessarily need all of these pieces of the cake, but this is what one of the cakes could look like. We have digital twins, which feeds off of and can feed off of artificial intelligence, but it has its own way of being. It's been around. We've been seeing it. I'll talk more about that. I've been asked to talk a little bit about blockchain or distributed ledger technologies. I'll talk a little bit about that. A little bit about robotics and drones. And then, of course, additive manufacturing or advanced manufacturing, if you look at the whole process as a whole. So first, I'll just look at AI, very, very brief, all of these topics. So when you look at artificial intelligence, it's just, you know, human intelligence that's exhibited by machines. That's really all it is. And then in the base of it, like a cake, you start with data science. Everything is based off of data. The intelligence is based off of something. So having data be there with these different algorithms that you have to put together, data is key. Validation of that data becomes more important if you're going to rely on artificial intelligence. How do you make sure from, you know, safety, security, that your data has not been tampered with? It is the original data. It is validated. A lot of those different technologies are out there, but more may be needed in the future. So at the basis of everything, as we saw in the cake, is data science. After that, depending on what type of data you can have language data, you can have you know, photos, videos, you can have numeric data. Actually, a lot of that language data gets turned into actually numeric type data. If you really want to dig into the data science piece, that's where a lot of that comes in. However, that will be for another seminar series. I'm not going to go into that. And then, of course, with that, then you have like, how do you use that data in another way, such as one of the options here can be machine learning. And then in depth of that is even like deep learning. And then you get to all of these different things that you've been hearing about. There's different types of learning that could happen. And then at the end of the day, then you have this so-called intelligence. It's just kind of mimicking what humans may exhibit from all of that. And then, of course, a lot of the things that we have been talking about or may talk about today, you see robotics is in there because robotics will, in the future, rely heavily on artificial intelligence even more than it already does. And so a lot of what we're talking about comes at a basis of, and its advancements will come from artificial intelligence as it keeps maturing. So just to kind of kick off some of the things you might want to think about and what might be covered in the future seminars, AI or artificial intelligence, when you're looking at plant operations, some things to think about are, yes, data, digital twins, and little time series informations that will all feed into and be advanced by different artificial intelligence algorithms. And even the user interfaces will be affected by this. Looking at computer vision, of course, if you have, instead of, you know, in a large language model, it's all about text. Computer vision is all about images. So looking at whether or not you can do comparison in images, how do you train an image type model? And that's all work that can be done and can have a real impact on plant operations. If you can do a lot of things visually, and if you're trending, monitoring, you know, performance, maintenance, a lot of that can be impacted and aided by computer vision. Oh, and I've already talked a little bit about the large language models and what that could impact. A lot of people have been trying to implement it into, you know, the work order processing. How do we do outage analysis and knowledge retention? So there are some areas where it's already been starting to work in, but it's that full model that you might want to do that leads you into, you know, automation at the full end. And those different advancements, you know, while technologically very, very interesting, when you look at safeguards, when you look at how you're going to implement it into nuclear power plant, then you have more considerations that you may have to think about and the basis of a lot of these future seminars. The next area feeds right into this. I've already mentioned for digital twins, it will be advanced highly by artificial intelligence. But what is really digital twins or digital engineering? It's all on this slide here. It's really a digital replica of something. So it could be a physical asset like a pump. It could be a layout of your power plant, or it could even just be a twin of your process. So if you have a process like is on the kind of the bottom of the slide, planning, design, procurement, construction, operations, if you even have modeled that process, that is a twin of what you're looking at, and it can have some impact. So if you're looking at that, either way, the digital twin is the digital version of it, can is either a model that can use the data from the physical asset or process, and it could, if you want it to, communicate with that process to give it feedback, to do optimization, to may have alerts or flags if something is happening. So this is a really good tool, but a lot of this, since we have a lot of legacy plants, like how do you put one of these together if you already have a legacy plant? Some plants have already started down this path and started, modeling some of their, maybe just a pump system, different systems. Some have tried to do the whole plant. I've seen a full twin, but it doesn't do full communication back and forth yet. So a lot of that will be advanced by artificial intelligence, a lot of these algorithms as well. So EPRI has done a use case value assessment. I actually did add the report down here for your knowledge if you want to go look at it. So people have around the world is like, where does it make sense to use this? Because right now, for things that are either already in operation, or if they're new and you have to create a full digital twin, that's a lot of work currently to do that. So when thinking about it, you have to choose when do you want to implement a twin and where, well, like a full twin, or maybe it's just a twin of a, just a pump because you just want to see the effects of just that pump. So a lot of these different things have to be considered when you're looking at these potentials for twins. In the future seminars, there'll be more discussions on this, some real life examples of where some of this has taken place. So I look forward to those seminars in the future as well. So another area that can be, advanced greatly by artificial intelligence, but can also be useful for digital twinning is robotics. Because the robot can actually go around the physical asset and feed back information to the digital twin if you have one. So right now, drones and robotics are really reshaping our industry. Just not the nuclear industry, it's reshaping the whole energy industry. We have been able to see in the last not 5 to 7 years, more drone usage is being used. It's already been demonstrated to eliminate hundreds of hours just because it can go around and you don't need a scaffolding now if you want to just image the outside of your containment building. This has already been demonstrated. We've been seeing it. And in conjunction with like video cameras, it can go and see what's there visually. And then it with looking at machine vision or computer vision, it's actually been able to then identify areas of like cracking of your containment and actually look at if you have past data, historical data, trending of what that might look like. So a lot of that has already been starting to be used. It's not widely used yet, but that is a technology that has been used more often now. And then of course you have robotics that can go around as well. We have, I'm sure everyone has seen, the quadrupeds moving around. The most popular right now has been Spot, but there's been so many. And then humanoid type robots are now becoming more to the forefront as they're becoming more advanced as well. And it says here you can use them to complete more hazardous tasks, meaning places that you probably would not want to have a human go into. For instance, high radiation areas, areas that it might be more tight, confined spaces. You can now actually put a robot or drone into those spaces. Of course, you need to make sure if something happens, you have a way to extract them. But they have been able to help out where you might not want to have a human go. So it's saving on a lot of dose for people, and it's creating a safer work environment for humans. In addition, of course, we have submersibles. They're able to go to places that are too dangerous for divers, or where you would not want to put a diver at risk. Sometimes you do have to send a diver no matter what, but now we have submersibles are able to do that. Of course, more advancements in that area and different types of underwater sensors are need to be had in order for that to be more fully envisioned and then implemented. And then, of course, as I said, it can build on both the digital twins and artificial intelligence. And so that is one way we can build on these successes, but I'm sure we have lots of innovative minds on this call, and I'm sure they have more ideas of where this could go. Now, looking at more going back, not as flashy, but like in the back end of data and looking at that, a little bit about distributed ledger technologies and the blockchain. The blockchain is actually just one type of distributed ledger technology, but this is not really well known to a lot of people. So it took me a while to actually learn about this myself. And I kind of embarked on learning about this probably about 4 or 5 years ago, because it was very interesting to me. I'm like, there's a different way of thinking about how you can look at data. So what is distributed ledger technology? So on this slide, we have centralized and decentralized. Distributed is really decentralized, where in a centralized model, it all goes into like one repository. Say like if you have the headquarters will keep all of the data. It is sitting there, and that is where you go back and forth with data. So all of the power plants, like on this slide, they will communicate with headquarters, and all the data comes back and forth through there. In a decentralized model, however, the data is kind of like in a cloud. We call it an ecosystem. So it is in an ecosystem where this data is communicated to everyone. Everyone has equal access to the data, and everyone also has access to help validate a lot of the data. In this way, you have a more robust data control. Because if it's centralized, if something happens, say to cybersecurity, to your centralized data source at your HQ, it could easily have some, safeguard implications. It could have some other, cybersecurity implications. But in a decentralized model, depending how it's set up, it is a lot harder to do this because a lot of people have, that repository access to it. They have the past validations of this data. So a lot of people have thought that decentralized might be the way to go, but it's a lot harder to implement. So this is an implementation type issue, thinking about it. So there are pros and cons to both centralized and decentralized modes of using this type of technology. But everybody hears the word blockchain. So I added a slide here on what is blockchain. So it's really, in a very simplified way, looking at data that's packed into a block. So you have the transition there, the data is in a block. That's why it's called a blockchain. And then this blockchain is shared among, this is the distributed part of it, is shared among those participants. And what happens in that block is that, say this block has, it's inspection data, and now you say, so-and-so signed off on the inspection data, so you're adding to the chain. You're adding this little block to the chain. So the block among participants are like, they will see the new block come on, so-and-so has added to this block. all of those participants or those computers who are looking at it will say, yes, that is a valid block. And then once it's approved by, it doesn't have to be approved by people, but approved by all of these different computers, then it can be added to the chain officially. Now, you probably have heard it is very hard to break a block once it's on the chain. That is true. It is virtually impossible to break the blocks once they've been added to the chain because of this consensus and approval by this distributed network. And then once that block has been officially added to this chain, then that information is then updated to all of the, people and the participants in the ecosystem. So then they all have a record of what was on the block. So this is how kind of a distributed ledger technology works, but this is how specifically blockchain works, because it's adding blocks to your chain of information. So just some examples of current uses of distributed ledger technologies in other industries. I'm not naming here who is actually using it, but some grocers are using it. I have heard a story of, not even a story, it's an example of where they're actually tracking where avocados come from, because there has been so many different, outbreaks. There's bacteria on them, like things that could make people sick. So they actually track using the blockchain where avocados are from, the farm all the way to the store. So it knows every stop of where it's gone and wherever every avocado from a certain region is actually going. So they've already implemented that. A shipping company is actually using it to track shipments, etc. I think if you look online, you can probably figure out which of these are actually already being used in other industries to make this robust chain of data, especially if you're tracking, where material is going, say like an avocado. And then one of the uses in nuclear could be if you're doing materials tracking, where has that material gone from cradle all the way to the grave? But that has, implications in safeguards and things like that that have to be considered before even being considered to be worked on. Oh, and I think I already mentioned this, but like these are some other use cases that could be used in the nuclear industry. I already talked a little bit about different supply chain. You could use it for cybersecurity to try to make sure your data isn't tampered with. It could be used in regulatory space and licensing, because then the regulator can track where like data is going and things like that. And you can also track where in the regulation and licensing pieces of document and data is going. There's a lot more areas that it could be used, but a lot of these have to be thought about very, very considerately before we could even try to implement them. All right, I'm going to speak a little bit about advanced manufacturing here. I think I'm checking time here. Okay. So advanced manufacturing, what does this really mean? Okay. It's has implications, and if you see in this little word cloud, there's a lot of different names and uses and processes that can be part of advanced manufacturing technologies. So there's additive manufacturing, which I think a lot of people have heard of, 3D printing. There's, welding can be part of it. There's advanced welding, PM HIP, electron beam welding, lots of different things. Even extrusion is on here. So there's a lot of things that go into having a full advanced manufacturing technology, depending on what environment, what you're trying to do. And then the value of this really is that you can have the components that you need at the time you need them. As you know, if you tried to get a full pressure vessel from anywhere, it's a long lead time if you haven't already been in the queue, or even a new steam generator. It's not easy to manufacture these, and there's not that many places in the world that can do that at this moment. And so because of that, it is an alternative supply chain. And then, of course, if we're looking into new nuclear, advanced nuclear, you can enable deployment faster because now you have an alternative way of supply chain. Interestingly enough, if you think about that, though, If you are doing advanced manufacturing, like, what does that mean for safeguards? What does that mean for a lot of, export control? There's a lot of different questions you may need to think about if you want to adopt this. But from a technological aspect, a lot of this is really, really interesting. It's inspiring. It's a really nice innovation that is being worked on. So just kind of like going a little bit more in depth to give people more of a feel for what this is. You can see on the left side of this, well, I guess, yeah, my left side here. I guess it might be your right side, but you can see a vessel head that is being, and a vessel that is being constructed. That is done with actually additive manufacturing with conjunction of some advanced welding and some PM HIP as well. So a lot of these are manufactured in parts. They're, of course, ground and polished to look really nice at the end, so they fit what they need to fit. And then, of course, because a lot of these pressure vessels are so large right now, they have to be put together with advanced welding. What I will say is that a lot of these methods currently are being worked on to try to make a big enough additive manufacturing with all of these things so you don't have to do a weld. Now, I want to see what that actually will look like at the end of the day, but that is current work that people are working on to see if they can't get a big enough rig to do all of this in one go. It's something to look at. But when you look at that, I mean, you still have to think about what materials are you going to be using. So looking at the codes and standards, what does the regulatory aspect look like if you're going to do this? Because typically in the nuclear industry, when you're looking at different components, there are codes and standards that go with a lot of that, especially if it's nuclear grade. So thinking about if you're going to do this in a very different way, not all materials can be additively manufactured. So there are different things to think about, and work is going through the code committees right now to try to get these validated, get some code cases put in, and then of course work with the regulators on accepting some of these as methods that could be used. And so it has been done. You'll see here on this slide, it is an SMR vessel that has been put together fully with advanced manufacturing, looking at a lot of the different types, with welding, PM HIP, different additive manufacturing techniques, and a full pressure vessel, reactor vessel was put together. So you can see it here. I believe it was completed in the UK. That was quite a feat that it proved it can be done. Now, how do we go forward from there? That is the next question. So now to kind of complete my talk, we can look a little bit into the future. And I put this here because you don't know where we're going to go with any of these things. But looking at the whole energy system as it is, what are the next technologies that we could be looking at? I don't know if anyone recognizes what's on here, but I do have a picture, of all of the different energy systems that could be working together. But I also have a picture here of a quantum computing system. That's that weird little hanging chandelier thing on the side there. Quantum technologies is really, really coming up quickly. A lot of research is being done into it. And looking into those technologies is kind of my next thing. I was introduced as, leading a lot of the quantum technology work. My biggest area of focus next year is actually going to be on quantum sensors and how that could be implemented into the nuclear industry. But unlike a lot of the technologies I just spoke about, like this is more at the beginning of the research where we're going to go with this. So really, stay tuned on where this could go and how this could actually, all of the different types of quantum technologies, how this could actually impact everything else I just talked about. And with that, I'm going to hand it back over to Eva to take us to the Q&A.
Thank you very much, Emma. Bravo to that. That was a very interesting overview of what is happening in the nuclear field in terms of emerging and evolving new technologies. I would like to add, for example, the use of robotics for decommissioning work, like we heard 2 days ago. And the IAEA also has a spent fuel pond verification robot that scans the spent fuel pond, which reduces the radiation exposure to the IAEA inspectors. And also the IAEA is looking at using this distributed ledger technology for nuclear material accounting. So I think once the IAEA introduces this, all countries will, this will be rolled out to all the countries that have NMAs and submit NMA reports to the IAEA. Without further ado, we have one question, actually 2 questions. I would like to repeat that the recording of all our webinar series will be available on the WIN Global YouTube channel. Our comms team will upload this recording there. It will take a couple of days, but you should receive an email once this is done. So we have one question from Fiorella Merma Velasco. Dear Emma Wong, thank you very much for your excellent presentation. My question is, how can blockchain technology be applied to solve problems in a nuclear power plant?
It's all about data. Data. So one of the areas, and Eva just kind of talked about a few uses, material tracking. It might help with how you do reporting to the IAEA that may be less intrusive. Maybe, I don't know. That's something for the IAEA to determine. However, one of the ideas that could go forward, but needs to be more fully vetted and implemented is, if you have like a qualified inspector. And I'm going to probably give out, we don't have a whole lot of time here, but like if you have a qualified inspector, how do you verify? It takes a while to verify the trainings they've had. It takes a while to verify, all their certifications and things like that. Imagine if you had qualified inspectors with blockchains, and every time they do something and they fulfill their hours and they know like all of these different things, and it's just put onto their blockchain, their private little blockchain of like all of their certifications. You could go in very easily and say, yes, this person is qualified to do all of this work. It's already certified on the blockchain, and you can actually move people through quicker through a process to get the power plant. It takes a while because there's a lot of training. Have you done this? Have you done, the rigging training, confined space, depending on what it is. And you have to get all that paperwork all together. And if you had it all done, it could actually maybe improve human performance, getting people where they need to be on time. Other ways is just if you are, taking data like a photo, you can actually add, blockchain it with the time, date stamp, all of the metadata is attached to it in a blockchain. And then every other time that it's updated with maybe another photo for trending, you have it all there. And so it may have like lots of different interesting ways that you could use it to help you truly validate, and maybe that you don't lose the data because it's all together on one chain. And if it's all on one chain, even it helps you with the regulator at that point as well, because you need to know where everything is for the regulator.
Thank you, Emma. We have another question by Ivan Anizukire. Thank you for the presentation. Have you thought of how risky it is for the nuclear sector to be controlled by AI? Excellent question.
Excellent question. The answer is yes. It is not something I don't think we're going to see anytime soon. I will say there always will be a human in the loop, likely in my lifetime. Now, in future lifetimes, I'm not sure what that will look like as the intelligence grows. However, looking at if you were to have a full, what was it? The nuclear sector. Yeah, if you wanted to have the full nuclear sector, or even the just say just a nuclear power plant, just one nuclear power plant controlled by AI, fully autonomous, AI is making all the decisions. We don't have enough compute power. We don't have enough data anywhere to even do that yet. So we will have to figure out a way, if we ever wanted to do that, like how will you deal with all the data that's needed? How do you make sure it's validated? Because you want validated data before an AI will make a decision. And there are two types of AI. If you have say we already do like Monte Carlo models, right? We already do models for a lot of different things. You can call that AI. A lot of people do. That's like AI 1.0, right? Like that's the stuff we've already been doing. But think about it. We already rely, we don't bring out our slide rules. We don't do the hand calculations anymore. We're just like, yeah, that's been validated. We say that is what it is. We say yes. So think about it. We already kind of have, you know, some sort of assistance here. And so it's going to be learning how much are you going to trust it moving forward. Smart people like Eva thinking about like all the other bad things that could happen and what we need to think about before we do this. And this is where conversations about what could happen, how do we keep bad actors out, and things like that will give people confidence to saying, yes, we can rely more on what it's telling us. Like, am I going to rely on like ChatGPT today to like run a power plant? I'm going to say absolutely not. Like, I'm like, it can't even get me like the simple questions about like, you know, things that I want it to do correct today. I think we have a long way to go, but questions like that is what's going to make it easier for us to think through these problems. And it may never come to be. It may be too risky at the end that we will never get there.
Thank you, Emma. Yes, that's very true. I feel exactly the same. We are reaching the end of our webinar. There's just one more question which you would like to answer by Sol Bustos Fierro. Hello, great presentation, Emma. Do you believe AI can replace a part of the operation crew in the control room?
I think maybe one day, but like right now, no. It's going to be a tool. It's going to be an aid. It's going to be, it's kind of like, you know, how you already have an alarm system for you to go pay attention to something. It's going to be an additional alarm system to help you pay attention to something or give you feedback. Did you think about this? But I don't think it's going to make decisions anytime soon in the control room. If you have heard about this, I'd like to talk to that power plant and how they got there. But I don't think you're going to see that anytime soon in commercial power. I think, you know, a lower stakes is if you could try to do it, you know, maybe in a test reactor, see how that works. There are lower stakes to going into a full control room right now for any decision making that should be validated by a human. Not to say that we're infallible, but at least, you know, it gives a one checkpoint that that we can look at.
Very true. I fully agree with you. So without any further ado, a big applause to Emma for her great presentation. Thank you very much from all of us. Thank you also for Xiaohong and your background support, and Holofellow for being today's webmaster. We will have our next webinar in about a month's time. You will all be informed about it, and please also follow our social media announcements. I also republish them, and also our two groups redistribute them. So we look forward to our second session, and I hope you can all participate again. So a big thank you to Emma Wong, to Xiaohong Cheng, to Holofellow, and to, of course, to all your participants for your interest in this topic, which I think is our future. Thank you, and I look forward to welcoming you in a month's time to our next full scope webinar. Thank you.
And thank you, Eva Jian.
Thank you, everybody. Have a good day or evening. Bye.